Okay, now this one gets a bit trickier. So there are going to be some instances where I'm going to tell you it's just better to go ahead and do the calculation. And there'll be some instances where it's much easier to just go ahead and use a factor. So let's try and be clear. And so to find the effect of changing one dimension, see how often the dimension will appear in the formula, all right, to find the exponent. So for lateral area, and I have to be clear here, I probably should have put a line, slant height on lateral area. So if I change the height or slant height on lateral area, they only show up once in the formula. So if I change it, then it will only appear once. So I can just go times a factor. So this is pretty straightforward. Now, if I change the height or the slant height, but I'm not changing the base at all, then there's no reason for there to be an effect on the base area. So I'm going to say no effect. So if I double the slant height without specifically saying I'm changing anything else on the base, then there is no effect. Volume, slant height and height, well, actually height and slant height are related. So if the slant height changes, the height changes. Then if I increase the height, the volume will change by that factor. It only shows up once, so my exponent is a 1. So I don't have to write exponents, so I just say times the factor. Now, apothem is a different creature. And apothem will actually change the perimeter, because if I double the apothem for, say, a regular hexagon, then all the other sides will have to be doubled. If I double all the sides, that doubles the perimeter. So for an apothem, it will affect the perimeter. Now, I should say that works well for a prism, right? For a cylinder, it's even trickier. This one, I have to say calculate, because what happens is if I increase the apothem, make everything wider, and then I increase, then that could change the slant height. So in that case, that's a tricky one to pull off. Now on the bright side, for base area, it's much more straightforward. The apothem shows up there right in the formula. But as I told you before, it also increases the perimeter. So in a way, it shows up twice in the formula. So you could say times the factor squared. For volume, we're only dealing with the exact height. So if my slant height changes, that's okay. The exact height's not going to change if I just change the apothem or any of the sides of the prism or the pyramid. So the dimensional change, it shows up twice in the base area. See right here, times the factor squared. So it will be times the factor squared here because it doesn't affect the height. Now, this is for a rectangular prism or pyramid. If I'm dealing with lateral area, you probably just want to go ahead and calculate this one, because if I double the length of the width, that could affect the slant height. It won't necessarily affect the height, and so that would be a straight calculate. For base area, if I say I double the length but not the width, or I double the width and not the length, that one's pretty straightforward. You just put in the factor. So if I double one side, then it's like I have twice as many rectangles, which means my area doubled. And for volume, volume only depends on height. So if I double the base, then that will double my volume. So it will only show up once with an exponent of 1, even though it can change the slant height. For cones and cylinders, and again, I have to be clear, if I change the height for something, then what I'm going to be doing is it will affect the slant height. Now, when I say if I change the slant height, but I'm keeping the radius the same, that will affect the lateral area only once. And again, remember, I'm only changing one dimension. As slant height and height are related. So then I would say times a factor. If I change the base area, and this should say pi r squared, not pi r2, if I change the height that's not going to have any effect on the base whatsoever. No effect at all. And then if we have lateral area is changed, if I change the height, it will appear in the, it doesn't affect the base area, but it does show up in the height. So it would appear once in that formula, so the exponent's 1. I just do times factor to the 1 power. For lateral area, if I increase the area of the circle, so instead of a 4 radius now, it's a 5 radius or an 8 radius, that does affect the radius right away. And it can affect the slant height if the height is still the same. So this is one of those that I would say go ahead and calculate it and figure out exactly what it is. All right. Radius is pretty easy to predict on the base area because if I, it shows up as a square in the base area, it shows up twice. So you multiply by the factor twice. So if I double the radius, then I would quadruple the base area. Radius does not affect the height. So if I double the radius, it's going to have the same effect as it did on the base area. So I would multiply by factor squared. Now for our last example, we're going to take a look at some of these and see how they would change things. Remember, if I double the apothem of a pyramid and I'm keeping the same height, this one's tricky. I would say actually go ahead and calculate this one because if I double the apothem, that's going to change the slant height. And slant height affects the lateral area. So if I keep the same height here, but I double 2r here, then this is going to change. And so it can show up in a strange way. So just calculate it. Base area is a lot simpler. If I double the base area here, and I did call that radius, I should have called that apothem, it's times 2 squared. All right. If I double the apothem for a pyramid, the height's not necessarily going to change, so it's still times 2 squared. So the base times height, the apothem will not affect the height, just the base with that 2 squared. If I divide the length and width of a rectangular pyramid by 4, what will happen? Well, the slant height could change, so I'm not going to mess with the lateral area. You're better off calculating that, okay? But the base area I can figure out. If I divide the length and width of a rectangular pyramid by 4, it's going to show up twice in this case. So I'm going to say divide by 4 squared. If I just divided the length by 4, then I would just have divide by 4 on the base area. For the volume, it's going to have the same effect it had on the base area. It didn't affect the height. And I think you're going to find that a lot. If the measurement doesn't affect the actual height of it, the biggest exponent you'll see is a square because it might affect the area with a square. It shows up twice, but it doesn't change the height. If I multiply the height of a prism, so now this is different, by 5, my lateral area should increase by a factor of, you might want to calculate this one because I'm thinking now that I think about my right triangle, if I double my height, my slant height may increase because the angle is going to change and it may not be quite that simple. So lateral area can really be tricky. As for a cone, and for the prism, for the prism it's easy because the lateral area, there's no slanting involved. All right, so if I triple the height of a prism, then I triple the lateral area. All right, now let's take a look at the base area. Multiply the height of a prism by 5. Well, that's not going to have any effect on the base area. No effect. Whoops. If I do multiply the height of a prism by 5, the volume is it's a prism, base times height. So the height is affected, the base is not, so it's just times 5. If I have the diameter of a cone, so instead of being like this, it's skinnier now, all right? So the base area, the diameter, if I have the diameter, I also have the radius. So it's like I'm dividing by 2, but the radius shows up twice in the formula, so it's squared. On volume, volume is, let's see, where is my volume formula for a cone? Volume is 1/3 base times height. Since that's height and base, and I'm not affecting the height, then I can have the same effect as I had on the base area. And we're almost there. If I triple the height of a prism, then there's no effect on the base area. And it's a very straightforward effect on the volume. It's just times 3. So I admit on these where you change one dimension or two, and especially if you're dealing with the lateral area, be careful about lateral area. I don't think you're going to run into that where it's just they expect you to simply apply it. But if you're dealing with base area or volume, you can see that those are pretty straightforward and that you can take those effects and predict what they will have on those calculations.